Hello, grade 7. So, welcome to another math lesson. I would like to say a big thank you to those of you who have been handing in work diligently. I want to give you a big well done. I'm very impressed with the quality of work that most of you have been putting into your work, and I'm very impressed. Let's keep up the good work, and hopefully, we'll be able to come back to school in March, and we'll be able to continue our school as normal. But while we are still at home, let's keep up the good work of working hard at home and watching all these video lessons and doing all the homework diligently. So thank you to those who have been handing in quality work. If your work is not that good, then I suggest you look at some of your classmates' work who have been handling it really well. Anyways, let's get on to today's lessons. We are on 5.8 today, which is actually the last lesson of chapter 5, changing fraction to decimal. This topic is rather simple. Many of you probably know how to do this already, but before we go into the actual changing fraction to decimal, there are some vocabulary that I want to talk about. There's two main vocab today. Vocab. First, we have something called terminating decimal. Terminating decimal. Now, the meaning of terminating decimal, it is a decimal that has a final ending ending digit. It has a final ending digit. It doesn't go on forever. Does not go on forever. So for example, if I have 2.5, that's it. 2.5, there's nothing afterwards. There are invisible zeros. I can say that there are invisible zeros right there, but these don't count. So, it has a ending, doesn't go on forever. That's terminal decimal, and then terminating decimal. Then the other one is called a repeating decimal. And what a repeating decimal is, it is a decimal that has non-zero digits that repeat at the end forever. Now, why did I say non-zero? Let me just quickly highlight this non-zero, is because these are zeros. I can repeat as many zeros as I want, but that doesn't count. So that's why it has to be non-zero digits that repeat at the end forever. So for example, if I have 0.33333, where it continues on, that's a repeating decimal. Another one can be 0.16161616, where the 1616 repeats itself forever. So it's any digits or sets of digits that repeat themselves forever is called repeating decimal. So these are the two vocabulary for this lesson. Let's get on with our examples. So example 1 will be converting or changing a fraction or an improper fraction. I'll put this in a bracket. Improper, in a bracket, fraction to decimal. The improper can be a bracket because both improper fraction and a normal fraction is done the same way. So I have two examples here. A, let's have 3 over 8, and then B, I'm going to use an improper fraction, 15 over 4. So what we do to change an improper fraction or a fraction into a decimal, the meaning of fraction, let's go into a bit of meaning first in this box. When we say A over B, it means A divided by B. That is the meaning of a over b. That is the meaning of a fraction. Whatever number is at the denominator, it means it is first divided by that number. It is a fraction, so it is a division. So that is what fraction means. So let's go on to our question. 3 over 8 is the same as 3 divided by 8. And how do we calculate 3 divided by 8? We're going to use long division. We have to use, okay, so let me write it out in steps. Step 1 is write fraction as a division statement. Okay, so that is writing, that's step 1, from the fraction to the division statement. Then step 2 will be use long division. So we have 3 divided by 8 is the same as 3 divided by 8. Now remember, for long division, we have whatever it's being divided by, that will go outside, and then 3, the first number, will go inside. So that's 3 divided by 8. And then we just work out the long division. 8 goes into 3 how many times? 0 times. So we write the 0 and add the dot, add a 0 at the end. 8 goes into 30 how many times? Goes into 30 3 times. That's 24. And then take the subtraction. That's going to be 6. Add a 0. 8 goes into 60 how many times? 8 goes into 60 6 times to be 48. No, 7 times. Oh, sorry, 8 times. No, 7 times. It's going to give you 50, what is it? 54. We have 64. Before 64 is 56. Sorry. Yeah, 8 times 7 is 56. Remember your times tables, guys. It's very important that you remember your times tables. And then take 60 minus 56 is 4. Add a 0. That goes into it 5 times. So 3 over 8, or 3 divided by 8, is the same as 0.375. So that's how you write it. So you can write out in the end, 3 over 8 is equal to 0.375. This is your working out. That will be working out. Please show your working out. I want to see your long division. Don't just write out your final answer. I want to see the working out. I want to see the steps that you did to do that. So moving on to B, this time we have a improper fraction, but it's still the same. Step 1, we write the fraction as a division statement. So let me do my part B over here. I'll move that over here. Move that down here. So 15 over 4. Step 1, let's write it as a division statement. So that is equal to 15 divided by 4. If you're not sure, let me just quickly write how to say it. Is said as A divided by B. So that's just in case you do not know how to say this. A divided by B. 15 divided by 4. And then step 2, you write it out as a long division. So we have 15 divided by 4. 4 goes outside. 4 times what? Sorry, wrong way around. Oh, yeah, it is correct. Yeah, 15 divided by 4. 4 is outside. Remember, it's the number, the second number goes outside, and then the first number goes inside that division. So 4 goes into 15 how many times? 3 times, to be 12. And then take the subtraction. 15 minus 12 is 3. Add a 0. 4 goes into this 7 times. 28. 2, 0. and then you add a, sorry, I forgot the dot here. Let me go back. Yep, 3 times for 12. Take the subtraction 3. 4 goes into 3 how many times? 0 times. So we have to add a dot, and then we add a 0, and then 4 goes into this 7 times. That is correct. And then you do the rest, and then that's going to be 3.75. So, this is how you do change improper fraction into a decimal. So that's it. Lastly, you just write 15 over 4 is equal to 3.75. So that's example 1, writing a improper fraction or a normal fraction into a decimal. Now, let's go on to example 2. Example 2. That will be changing mixed numbers into decimal. So let's say we have a mixed number 15 and 2 over 5 as a mixed number, and we want to change it into a decimal. Now, if you remember, the meaning of mixed number is actually 15 whole part plus the decimal part, or the fraction part. So this is essentially the same as 15 plus 2 over 5. That's what we did last lesson. And so we can actually now just change 2 over 5 into a decimal. And so 2 over 5 as a decimal, I can write my working out here. 2 over 5 is the same as 2 divided by 5, which is 2 divided by 5. 5 goes into 2 0 times, and then we add a dot, we add a 0. 5 goes into 20 4 times to get 20, and that's it. And so that is the same as 0.4. And then I can write my whole statement. 15 and 2 over 5 is the same as 15 plus 0.4, which is 15.4. Done. It is actually more simple than you think. So that is example 2, and we have one more example. But before I go into that example, I want to talk about something called repeating decimals. Now, let's make a mini subheading: repeating decimals. So repeating decimals are decimals that repeat itself. For example, if I have 0.3333, that goes on forever. How do we write it? We actually write it as 0.3, and we put a line. So we write a line, write a flat line on top of the digit or digits that repeat forever. So that's how we write a repeating decimal. Now, another example, if I have 0.135, and it goes on forever, and you can see that these sets of numbers, that 1, 3, and 5, 1, 3, and 5, 1, 3, and 5, they repeat itself, then we can write that as 0.135, and I'm going to put a line on top of all 3 of the numbers to show that the 3 numbers repeat itself. Now, sometimes the decimal will start off without repeating, and then there will be some numbers that repeat itself. So for example, if I have 0.15666, something like that, and then you can tell that the 6 goes on forever, then the 1.5 doesn't repeat. This part doesn't repeat, and then this part repeats. And so we will write this as 0.15, where that doesn't repeat, but now the 6 repeats. So I'm going to write the line on top of the digit that repeats. And same for another example. If I have 0.1, I always like using 1, 1, 8, 2 5 2 5 2 5 2 5, and it goes on forever. Well, the first part doesn't repeat, the 1 8 doesn't repeat, and then the 2 5 2 5 2 5 keeps on repeating. The 2 5 2 5 2 5 2 5, and so on. And so we would write this as 0.18, and then I can write the 2 5 with a line on top of only the 2 5 that repeats the digits that repeat itself. So that's how we write repeating decimals. So let's get on with some examples. I have two examples over here. So this will be example 3. Example 3. And let's just call this repeating decimals. So A, we have 6 over 7, and then B, we have 1 and 5 over 33. So we have one fraction, normal fraction, and then one mixed number, and we want to turn them both into decimals. So first of all, 6 over 7, I'm going to write this as a division that is the same as 6 divided by 7, which is going to be 6 divided by 7 using the long division form. 7 goes into 6 how many times? It goes into it 0 times. So I'm going to put the 0 point over here, add a 0 down next to the 6, and then 7 goes into 60 how many times? 7 goes into 60 8 times. 7 times 8 is 56. I'm quite bad at my times tables too, so you guys should remember. And then we have 60 minus 56 is 4. 7 goes into 40 how many times? 7 goes into that 5 times to get 35. And then that also, 40 minus 35 is 5. Add a 0 there. 7 goes into 50 how many times? That is going to be 7 times. And then that's going to be 49. And then we have 1 remaining. Add a 0. That goes into it 1 times. Oh, it seems like it's just repeating itself. No, not repeating. It just goes on. Let's continue. Let me see if I did something wrong. Let me move this to another place first so that I have a bit more space. Let's just see what happens if we continue. 7 goes into 10 how many times? That's 1 times. That's 7, and so we have 3. Add a 0. 7 goes into 30 how many times? 4 times. It gets 28. And then we have 2. Add a 0. 7 goes into it twice to get 14. And then we have 6. Add a 0. And then 7 goes into 60 how many times? 8 times to get 56. And then that becomes 4. Now we can start to see a pattern. Yes, we can now see a pattern. This part, the one that I circled in green, you would see that it is kind of, now it is starting to repeat itself. And so I can just continue. I know that this is going to be 7 goes into it 5 times to get 35. And then it is now the same. This is still the same as, this is the same as this part. And then we have 56 over here. We have 40. We have 35. They all repeating itself. So if I'm going to write this one more time, this is going to be 7 1 4 2, and then it's going to be 8 5 7 1 4 2, and it's going to repeat. And so the repeating part is all of 8 5 7 1 4 2, all of it. 8 5 7 1 4 2, 8 5 7 1 4 2. This all repeats itself. Now I know it's a very, very long decimal, but it is still a repeating decimal. And so we're going to write this. So 6 over 7 is equal to 0.857. Let me just make this a bit smaller. 8 57142, and I'm going to put a line on top of all of it. So that's part A. Now, we have a second one, 1 and 5 over 33. I don't need to worry about the 1 because it's just 1 plus 5 over 33. And 5 over 33 is the same as 5 divided by 33. And using long division, 5 divided by 33, it's going to be a little bit hard this time. 33 goes into 5 0 times, so that's 0 point, add a 0. 33 goes into 50 1 times, and I'm going to put 33 here. And then 50 minus 33 will give me 17. 33 goes into 17 0 times. And so I still add a 0, doesn't matter. And then 33 goes into 170. Let me just quickly check. 33 goes into it, is it 5 times, I believe? Yes, 5 times. And that will give me 165. I take the subtraction, that will give me 5. And then 33, add a 0. 33 goes in 50 1 time. That will give me 33. And then I have 17 remaining, add a 0. And then take the subtraction. Oh, sorry, that gives me 33 goes into it 5 times to give me 165, and it goes on. So I can see that there's going to be 0.15151515, and so on. And so I can tell that it is a repeating decimal. And so when I add it together, this is going to be 1 and 5 over 33 is the same as 1.1515, and it continues, which is 1.15, and I'm going to put a line on top of the 1.5. So that's how we write fractions and mixed numbers, improper fractions, into decimals. So that's it for today's lesson. Your homework, yes, there is homework. Homework questions will be exercise 5.8, question 5, 7, 9, 11. Then we have 19, 23, 25, 27, and then 31, 35. And then we have 43, 45, 43, 45. And then we've got some problem solving, 49 to 51. And then lastly, question 53. Please complete your homework. I know it seems like a lot of questions, but most of these questions are very direct. It's just asking you to divide them and then change it into a decimal. So it shouldn't take too long. If you have difficulties, if you have any questions, make sure you post them either on the collaboration space in the homework query section or the class query section if there's anything you don't understand in this video lesson. Thank you for watching. Please complete your homework, and I will see you in the next lesson.